Okay, so what do we do on this problem? Well, again, the question is, not when, but can we just cancel out arc cosine and cosine, right? We'd like to just go boom, boom, because they're opposites, right? Can't we just cancel out like that? Isn't the answer just negative 3 pi over 4? Well, not always. Sometimes, yes, only when the argument, negative 3 pi over 4 in this case, is inside of the limited domain. It's got to be inside the limit. Remember, for the inverse trig functions, we had to limit the domain because we only wanted one answer to all the questions. So that's presented us with all these trickeries. Okay, well, let's go look for the limited domain. So you come on down here to the notes. This is why I emphasize that you want to put these notes. These are the exam 2 notes. These are really helpful. I really encourage you to put these on your notepad for exam number 2. So here we go. We're doing, oh, and I didn't fair. Was that an answer or an angle? What is that? It's an angle, isn't it? This right here, because it's inside of a cosine. So inside of a normal cosine function, we put angles, don't we? And get out answers. And so this is an angle. So negative 3 pi over 4 is an angle. So let's go look at the limited domain for angles for cosine. So cosine angle, this is limited domain, between 0 and pi. Oh yeah, right? Remember, he goes 0 to pi for the inverse cosine. So the angles have to be 0 to pi. Yeah, okay, right? He goes 0 to pi. So let's go back to him. So the limited domain then is going to go like 0 to pi. So here's the LD, the limited domain. So where's negative 3 pi over 4? Well, he's about right here. He's not in there. So no, he's outside of the LD. He's outside. So what does that mean? That means we can't just cancel these guys out and say the answer is just simply negative 3 pi over 4. It's not that simple. But also the answer will not be D and E. No, there will actually be an answer to this question. Why? Well, because angles, you can always add 2 pi or subtract 2 pi. It's like a clock going around 12 hours later. It says the same thing, right? So if you have an answer, we have an angle this time. Negative 3 pi 4 is an angle. If you have an answer that's outside of the limited domain, that's when it's D and E, because you can't mess with answers. Answers are not like a clock, but angles are. Angles, if they give us an angle that's outside of the limited domain, you can always add 2 pi or subtract 2 pi until you get something that comes back. Now, specifically, what are we going to do? This is where I encourage you to look closely at the notes. Here they are. If it is outside of the limited domain and it's an angle, that's us, right? Negative 3 pi over 4 is an angle outside of the limited domain. What do you do? Well, again, then we cannot just cancel, as we said. But there will still be an answer. It's not going to be D and E, as we said. It's not D and E because it's an angle. No matter how big an angle is or small, we can add or subtract 2 pi. All right, so now, specifically, here's the game plan. Add or subtract 2 pi from the angle until one of 2 things happens. What 2 things? It's either on the unit circle or it's within the limited domain for the angle. Are you hearing that? Trying to make this as clear as I possibly can. So when you've got an angle outside of the limited domain, what do? You add or subtract 2 pi, watching all the while to see if one of 2 things happens. Does it suddenly appear on the unit circle? Or does it suddenly, because it wasn't originally on the unit circle. Negative 3 pi over 4 is not on the unit circle. Or does it suddenly appear back in the limited domain? It wasn't originally in the limited domain, but maybe after adding or subtracting 2 pi, it'll suddenly come back into the limited domain. If it goes back in the limited domain, that's the easiest case of all. You just cancel out the 2 functions, right? Once you're back in the limited domain, that's nice. Ours is going to come back onto the unit circle, which means you need to work out the problem on the inside. I gave examples of this down here. You can read them on your own time. I'm going to do that example right now with you. So here we go. So we're going to take this negative 3 pi over 4, which is outside. We're going to try to bring it back inside by adding 2 pi over 1. So I've got to multiply top and bottom by 4, don't I? So this becomes negative 3 pi over 4. Give us a little more room here. Plus, and this will be 8 pi over 4, which comes out to be positive 5 pi over 4. Now where's that? Did that bring it back into the limited domain? No. You know what that did? That shot it just past the limited domain. 5 pi over 4 is, well, how do you know? Because this is 1 pi, which is the same as 4 pi over 4, right? 4 over 4 is 1. So 5 pi over 4 is more than 4 pi over 4, isn't it? So when we added 2 pi here, by adding 2 pi, we jumped completely over the limited domain. So it doesn't look like there's any way we're going to get back in the limited domain. Right? Well, so now subtract 2 pi. Well, you go right back to here. Well, add 2 pi again, back and forth, back and forth. You're never going to get in that limited domain. You're jumping over it. The 2 pi jump is just too big. We're not going to get in the limited domain. But, so let me write that. So that's not in the LD, but 5 pi over 4 is on the unit circle, right? Let's go down to the unit circle. 5 pi over 4, that's right here. We're back on the unit circle. See it? 5 pi over 4 right there. So we're on the unit circle. We're in business. So those are the two things you look for. You add or subtract, and I'll finish it. We're not done yet, but let me say it again. You add or subtract 2 pi. When your original angle is outside the limited domain, you add or subtract 2 pi until your angle jumps back into the limited domain, which it didn't, or jumps back on the unit circle, which it did. So what do you do when it jumps back on the unit circle? Now work the problem starting on the inside. That's the key point. It's in the notes. You can read it. So let's go back to the original question. What was the original question? It was, we've done so much work on this now, arc cosine of cosine. Okay. It was arc cosine of cosine of minus 3 pi over 4. Well, now that has become, just change the colors here for clarity, arc cosine of cosine. And negative 3 pi over 4, we've added 2 pi and it's become 5 pi over 4. And now we can work the problem starting right in here, right here, just the inside. So just the inside, and then we'll do the outside later. Work it from the inside out. What's the cosine of 5 pi over 4? Just do the inside first off, because you can do that now. Now you can do that. We couldn't do it back with negative 3 pi over 4. That's not on the unit circle. Well, maybe you could, if you know how to find that on the unit circle. It's not really directly on the unit circle, but you might be able to do it. But anyway, for sure we can do this. 5 pi over 4 is for sure on the unit circle. Go to the unit circle. There it is. 5 pi over cosine sine. Cosine is negative root 2 over 2 at 5 pi over 4. So there we go. Negative root 2 over 2 from the unit circle. Okay, so what? Well, now this problem has become arc cosine, and then the inside, oops, sorry, I'm a little big. The inside has become negative root 2 over 2, right? This inside has become, I did the inside, negative root 2 over 2. Now it's just an inverse cosine question. We can do the inverse cosine of negative root 2 over 2. Let's go do it. You know how to do that, right? We're doing arc cosine of negative root 2 over 2. You know how to do that. This is an answer, right? It's reverse. And you're looking for an angle. And remember, now, careful. Inverse cosine, you only look in these two quadrants. Now you might say, well, Mr. Chairman, why don't we go right here? That's where it came from. Well, that's because we did regular cosine to begin with, right? Let's look back. Make sure we're clear here. That was regular cosine. Yeah, so for regular cosine, you can go anywhere you want. So we went to 5 pi over 4, and there it was. But now we're doing arc cosine, inverse cosine. That's limited. That's the whole deal. These inverse trig functions are limited. That's why we're having all these difficulties. So regular cosine was there. Yeah, that's great. But inverse cosine, we can only look between 0 and pi, the top two quadrants. So where do you see an answer negative root 2 over 2? Cosine sine right there. There's cosine answer negative root 2 over 2, 3 pi over 4. 3 pi over 4. There's the angle that makes that happen. And that's our answer. 3 pi over 4. So we worked the problem from the inside out. That's what happens. You know, when your angle is outside of the limited domain, you try adding or subtracting 2 pi until that angle jumps back in the limited domain. That's the easiest case. Then they just cancel. Or if it doesn't do that, it jumps past it, then is it on the unit circle? So you're looking for one of those two things to happen. Either the angle jumps back into the limited domain or back on the unit circle. Ours jumped back on the unit circle. So then I just worked the problem starting on the inside. I did the inside, cosine of 5 pi over 4 using the unit circle, negative root 2 over 2. So the inside became negative root 2 over 2. Then I did arc cosine of negative root 2 over 2, again on the unit circle, but only the top two quadrants for inverse cosine. Found it right there, 3 pi over 4. Solve the problem from the inside out. There we go.